today we will continue from the last class again from this chapter electricity, and today we'll do the last topic, and after that we'll do the problems with this topic. And today we'll learn about the electrical symbol. Today we'll learn about electrical symbol. Okay, these electrical symbols, there are so many, but we'll learn only the most important uses in this chapter. Okay, and then learn about the circuit diagram. Then also we'll learn about the electric circuit, we'll learn about electrical symbol, circuit diagram, electric circuit, and then we'll learn about the series and parallel circuit, and also the expression of series and parallel connection. Then that will be the last topic of this chapter. This will be, and then in next video we'll do the problem related to this. Then after that we'll start the heating effect of electric current. But that topic is not important with this coming exam. Okay, it may be important in 2023, but in 2022 it's not important. Okay. Let's start this electrical symbol. Okay, electrical symbol. What's the meaning of this electrical symbol? Mean any diagram, any example electric bulb, example a switch, example a refrigerator, a TV, or a mobile, or a socket, whatever. When we draw in a circuit, example series circuit or parallel circuit, we will come to that. What is a series circuit, parallel circuit? When we draw it in a copy, when we do some problems, then we have to draw a refrigerator, we have to draw a TV. When we do some problems, then that will be a tedious work to do when we solve a problem. Then in that case, we need a symbol to represent a symbol of electric bulb, to represent a switch, and also to represent the socket, represent the key, represent the battery, the source of supply. In that case, we need electrical symbol, because if we draw the actual image or the actual figure of those electrical appliances will be a tedious work when we solve the problems. Then in that case, we need electrical symbol. Example for a wire, a connecting wire. This is a symbol we just draw like this. Okay, this will be a wire, a connecting wire. Now next, if a wire are joined, if two wires are joining, then that will be symbol like this. Two wires are joining. Now this is one wire, now this is one wire are joined. Okay, then this point will be called as the junction. What do you call this point? This point will be called as the junction. Okay, now this is a connecting wire. Then this is when two wires are joined. Then when wires are crossing each other, okay, let's say this is a wire, and one more wire is coming from here, but we won't draw like this. This will be confusion. Then this is not a crossing. Then for crossing, we will draw like this. For crossing, we will draw one wire from here, and we show in this form. Now this is the wire, they are crossing each other. Okay, now this is connecting wire symbol. Now this is when two wires are joined. Now this is when two wires are crossing each other. Now remember this symbol. Okay, then for cell, please don't confuse what is cell and what is battery. A cell is a device which convert chemical energy into electrical energy. A cell is a device which converts chemical energy into electrical energy. Okay? Or a cell is a source of energy. But battery is a source of energy. But battery is a combination of two or more cells. It's called battery. Battery is a combination of two or more cells. But cell is a device which converts chemical energy into electrical energy. Battery and cell are the same, but cell is a singular, but battery is a plural. Cell means only one, but battery means more than one. Now let's draw a symbol for cell. Okay. Now cell. Cell was a symbol. We'll draw like this. Now this means only one cell. Okay. Now this is minus. This is a negative terminal which has a lower potential. Positive terminal which has a higher potential. Okay. Now what about battery? The symbol for battery will be, okay, example, I will join three cells. I will join three cells. Then this is a one cell. Then this is two cells. Then this is three cells. Now minus then plus. So both cells are nothing the same, but cell is one. But battery is more than one. Okay, here how many cells? There are three cells. Combined together, connected in series, will be called as battery. But in cell, connected in series, connected in parallel, we won't do in this topic. It is not yet in your syllabus for cell combination. Okay, it's only one topic. That is combination, not only about resistor. We will come to that. Okay, now. This positive or this negative, only know what's meaning of this negative is a lower potential, positive is a higher potential. Okay, now this will be cell and a battery, then we will come to next okay, fixed resistance. Fixed resistance or resistor. Okay, what's meaning of this fixed? Fixed means we cannot increase or we cannot decrease the amount of resistance. You already know what's meaning of resistance. We have taught in previous classes, in previous video. That resistance means the obstruction given to the flow of current in a conductor. Okay, then fixed resistor means a fixed resistance. That's the resistance that we cannot change. Once we connect it, that cannot change. Okay, that's a fixed resistance. Then for that, symbol will be like this. That will be the symbol. Or in some textbook, you will see like this. Most of the foreign textbook and this form for resistor. Okay, then a variable resistor. A variable resistor. Okay, example, you can say, what is this resistor? Resistor means it's not a particular. This resistor is not a particular material. It's not a particular device. Resistor means we can denote for TV. We can represent for refrigerator. We can represent for electric motor. Okay, this resistor means just to represent for different types of electrical appliances. Okay, then for that we just put symbol. If we mainly deal with electric motor, yes, there is a symbol for electric motor. But if we don't need an electric motor, just we need the flow of current there, then just put this symbol. We consider electric motor as a resistor. But if we mainly with electric motor, then we have to draw his own symbol, and we learn about his characteristic, his features, his working, his principle, whatever required to learn. But here we don't need those. We just learn it generally, then all we take as a resistor. For TV also we consider a resistor. Then for washing machine also we consider as a resistor. Because every material where the current flows, there will be always the effect inside that. What happens to the current? Whether the current will increase or decrease, whether that once ever the current flows, all the materials will get heat. Then that will consider as resistor. Now what's a variable resistor? Variable resistor, like here, fixed resistor means we cannot change the value of resistor. But here, variable resistor means we can change it. We can increase or we can decrease it. If you want to increase the resistance, we can use this. If you want to decrease it, you can use this. And this will be denoted by this symbol. Same like this one only, but there will be an arrow here. Now this arrow shows that this resistance or this resistor can change the value. Or this variable resistor sometimes called as rheostat. Sometimes called as rheostat. This symbol for this is sometimes we draw like this. Okay. Now don't confuse what this means, what is this and what is this. Now listen, this I will say. If you saw some circuit diagram where this symbol is there, then it means variable resistor. Or if you saw this also, or if you see this also, it is a variable resistor. Or both of this we can call as rheostat. And what is this rheostat? You can say. Rheostat is like a resistor. It's like a resistor only, but there is a difference. Resistance means once we set resistance, that we cannot change the value, fix. But rheostat means we can. Rheostat is a function of rheostat is to adjust the flow of current. What's the function of rheostat? To adjust the amount of flow of current. Remember this. Maybe here in class 10 you don't need that much what is rheostat, but in 11 and 12 you need this rheostat because you will do practical by using rheostat. In class 10 also some school they used to do experiment, and some school have not yet do experiment. That's why it's not that much important. But still you have to know what is rheostat. Rheostat means the instrument which adjusts the amount of flow of current. If you want to increase the flow of current, adjust this. If you want to decrease the flow of current, adjust by using rheostat. Okay, then what else? We need that much. Okay, key, switch. Okay, symbol for switch. Or what types of switch is this? This is called open switch. Open switch. Or unplug key. Or what? Unplug key. Means we are not yet plugged or we are not yet connected. Then what is the next? Close switch. Close switch. Now this is open switch. You know what is this open switch? That when you on and off. When you on and off. Okay, you charge your mobile. You're charging your mobile. You on the switch. Means close switch. On the switch here is a close switch. When you charging your mobile, you on it. You switch on the switch. The switch. Then your mobile are charging. But here we call as close switch. That on the switch means close switch. Open switch, if I can answer this is as off. Open switch means off, and close switch means on. We will come to that. Why call this open switch as off and close switch as on. Then this will be called as or plug key. Or okay, symbol for this would be or this would be the symbol. Now remember, the symbol for open switch and the symbol for close switch. Close means on, open means off. Then what else we need, which is more required here? Okay, electric bulb. Now symbol for electric bulb. Now this will be the symbol for electric bulb. Symbol for electric bulb. Okay. And still two more important symbol. Ammeter. Okay, what is this? Ammeter. You remember? Do you remember what is ammeter? Ammeter is an instrument which used to measure electric current. And one more, voltmeter. Okay, what is this? Voltmeter. And remember what is voltmeter? Voltmeter instrument used to measure electric potential. And please remember this symbol because this only we will need here in class 10. Then when we draw a diagram, then I won't draw the real picture or the real figure of voltmeter, real figure of ammeter. Just draw those symbol only. Symbol for voltmeter, then symbol for ammeter, then symbol for mostly key are used this one for closed switch, and for open switch are used mostly this one. Okay. Then now this will be the symbol, and remember the resistance symbol will be this rheostat, this one or this one. But mostly for rheostat I'll use this one. But only in one diagram we will need this one. Then in supply source there will be the cell or battery. Whenever they said source or energy, whenever they said source or energy, this will be. Okay. Or if they said alternating source, this cell and battery will be called as a DC source. What is this? A DC source. Cell and battery will be called as a DC source, and if they said alternating source, then that will be symbol like this. This will be the alternating source. If they said it is connected to an alternating source, then we have to draw this symbol. Okay, alternating source will be the symbol. Then if it is DC source, cell or battery. Okay, then we draw this one. Then we finish electrical symbol. Then we'll start electric circuit. Okay, now we finish this electrical symbol. Then I will come to circuit diagram. What is the circuit diagram? Okay, let's start with this. Circuit diagram. So, because when you do experiment, they'll give you a real voltmeter or real ammeter. You have to connect it with a wire, and so many instruments they give you a switch. But when you draw in a diagram, you don't need to draw the real figure. You have to draw with symbol, and that will be a circuit diagram. What circuit diagram? A diagram which shows various electrical components. Okay. The diagram which shows various electrical components connected in a circuit, either series or parallel, in aid of symbol. In aid of what? In aid of symbol. Just remember that. Mean a diagram which shows electrical appliances or electrical components connected in a circuit in aid of symbol. Okay. The diagram whose electrical appliances or electrical components What is this electrical appliances or electrical components? These are the electric instruments that you use at home, like refrigerator, TV, mobiles, then washing machine, heater, rice cooker. That all we call as electrical components, and that mostly gives a symbol resistor. Okay. The diagram whose electrical components are the diagram that shows. Okay, that is it. Diagram whose electrical appliances or components are connected in an electric circuit, in A of symbol. In A of symbol is called circuit diagram. Then don't confuse what is a circuit diagram. Okay, let me give you example. Example here, there's a resistor. Here there's a resistor. This resistor is denoted with R, that's a resistance. This is a resistor. What types of resistor? It may be your electric heater. And this resistor is connected to, let's say, is connected to a battery of how many cell? 2 cell. Let's say this resistor is connected to battery, and then this resistor, let's say, is connected to a, okay, let me employ this direction. Let's say this resistor is connected to a switch. Okay, now this is a closed switch. Closed switch means the current can flow through the circuit. If it is open switch, the current cannot flow. That's why open switch, the current cannot flow, mean off, mean no current. Then closed switch means the current can flow through our circuit. Then that is current flows is there, the current is there, then it is on position. Okay. Now, what about voltmeter? How it is connected? You remember from when we read about voltmeter? Voltmeter is a high instrument device. It is always connected in parallel. Then here also, where we have to draw that? Parallel. Parallel means we have to draw this. Voltmeter symbol. Okay, got it? Then, now I want to know how much current flows here. Then let me put here ammeter. Ammeter. Remember, ammeter is always connected in series. Then I'll connect it directly like this. Or I continue this side. Okay, let's make this small and then make it down. Okay, then next, what else? Okay, I want to adjust the flow of current. I want to adjust the flow of current. Then I'll put what? A rheostat. This will be the rheostat. This will be the voltmeter. Then this will be the ammeter. Okay, that's it. This much is enough, I guess. Just an example. Got it? Now, example. If I ask you to draw a circuit diagram, then I'll draw a simple diagram. Okay. Or, and one more. If they ask you to draw a circuit diagram for the verification of Ohm's law, from that, we already did about Ohm's law, but I didn't draw you a circuit diagram. But now, in that case, if I ask you to draw a circuit diagram for the study or verification of Ohm's law, you can draw this diagram. This is enough, because we'll study the verification of Ohm's law. We just need the voltage and the ammeter, and also resistor R. Because in Ohm's law, V is equal to I R. Then we need resistance, we need current, we need voltage. Then we all get here. This is the supply voltage and the supply current. And this will be the voltmeter, will read the value of voltage. And this ammeter will read the value of current. And then once we get the value of V, once we get the value of I, we can find the value of R. Then what's the resistance of this resistor? We got it from here. Then, now, let's say at a particular current I is equal to 10 ampere. Okay, how much? 10 ampere, then I will adjust from here. How to adjust 10 ampere? Adjust from here. Rheostat. Rheostat will adjust that. Then once we adjust this rheostat, then this ammeter will show the deflection up to how much? 10 ampere. Now if I want to reduce that, then again adjust from here. Then let's say I is equal to 8 ampere. Okay. Then once you change the value of current, then voltage also are changing. But remember, once I and V are changing, R does not change. Remember that R is a constant. But remember, I told you R is constant at a particular temperature, at a particular room temperature, means surrounding environment. If we take from one place to another place, example here are cold, then we go to another place which is hot, then that the resistance of that particular, mean resistance of this resistor are changing. Then we'll check example. You take I is equal, okay, we'll start from 2 ampere. Then how to get 2 ampere? Adjust from here, rheostat. Once you adjust from here, check here, 2 ampere. And once you get a 2 ampere, then note the value of voltmeter. Okay, you adjust from rheostat, you got the value of ampere, you got value of current 2 ampere. Then once you get that, then check source value of voltage. And once you get value of voltage, then note down. And once you note down, then do next. Okay, let's say I is equal to 4 ampere. Again increase. Then once you increase, how we get that increase? Adjust again from rheostat. Then again check the reading here. Then once you got that 4 ampere, then check again the value of voltage. And after that, note the value of I, note the value of V. Then once you finish the note down, let's say example 10 observation, when you do an experiment. Example, you do 10 observation. Then you calculate the value of R. Then from that 10 observation, you can get the value of R at that room temperature. Okay. Now that will be the verification of Ohm's law. And once you finish to draw that, once you finish to do this, you will get the value of, okay, let's say at I1, you get the value V1. At I2, you get the value of V2. At I3, you get the value of V3. Let's say I1 is equal to 2 ampere, you read it from here by adjusting the rheostat. Then once you read that, then check what's the value of voltage, then you note it here. Then you take here example I2 is 4 ampere, then again adjust from here to get at 4 ampere. Once you finish to adjust that, then check again value of voltage, then you got here some value. Then you continue up to 10 and 10 observation. Then once you finish that, then you draw a graph. Then draw a graph that will be VI characteristic. VI characteristic. V means voltage, I means current. Then once you draw a graph, you will get straight. Then this will be the verification of Ohm's law. Means we have to get this line as straight. Why? Because this resistance should be the same. Here, I1 is and V1. If you divide V1 by I1, we have to get R. Then if we divide V2 by I2, also I have to get R. Means this value has to be the same. Okay. Whatever we take value, if increase the value of current, but this value of R should remain the same. Okay, then that will be the verification of Ohm's law. Then the circuit diagram will finish. Electrical symbol, the circuit diagram finish, verification of Ohm's law. And remember this graph for Ohm's law. If for those students who got to do experiment, you will understand it very clearly. And for those who are not yet, you won't get to do experiment, you will understand it more in class 12. Okay, but here also if you listen properly, you get. But maybe you don't understand how that case because you don't get to do by your own. Okay, this is just an explanation, theory. Then, okay, now this will be the end of circuit diagram. Then now let's come to electric circuit. Let's start first this one. Okay, now we come to this last topic, electric circuit. Because this series in parallel also is under electric circuit. Okay, now what is electric circuit? Electric circuit is a continuous conducting part. What's the meaning of that? Continuous conducting. Conduct means that the current can flows. The current can flows throughout the circuit. Means it continuously conduct. It does not stop at some places. Okay. Let's draw some diagram here. Let's say here is a resistance R1, then here also again one more resistance R2. Let's say here is a ammeter. Then here is a battery, plus minus. Okay, example this much. Okay, let me put one more that will be important switch. This is a closed switch. Now, what is a circuit diagram? Or no circuit, electric circuit. It is a continuous conducting path between what? Between the terminal. This is source. I told you from when I explained electrical symbol, I told you this is a DC source. Now this is a source. Now look here. This negative and positive, this is called terminal. Negative terminal and positive terminal. A continuous conducting path between the terminal. These are the terminal. Between the terminal of the source between terminal of the source and the electrical appliances. Okay. Connected what? Connected with a connecting wire. These are the connecting wire. What is a electric circuit? It is a continuous conducting path between terminal of a source, comma, connecting wire, comma, and the electrical appliances. In such a way that the current flows through it. In such a way that the current flows through it. If there is no current flows, okay, we'll come to that. Now, current flows through it means this is a closed switch. If the switch are closed, then the current can flow out. Okay, we'll come to that. What is closed? Okay. Now, what is a electric circuit? A continuous conducting. Okay, write the definition here. Electric circuit. A continuous conducting path. Path means like a footpath that the current can flow. Okay, that current can go. Okay, continuous conducting path between a terminal of a source. Terminal here means this negative and positive. Connecting wire and the electrical appliances. Appliances connected in such a way that current flows through it. It's called electric circuit, and this will be the electric circuit. Now, what's electric circuit? A continuous conducting path means the path where current can pass through continuously between a terminal, between negative and positive of a source, connecting terminal of source, connecting wire and the electrical appliances. Electrical appliances mean ammeter, voltmeter, resistor, so many types of electrical appliances connected in such a way that the current can pass through it. Okay, if the current can pass through, then what's the use of electric circuit? We need a current to pass. Okay, but electric circuit, it has two types. That is open circuit and a closed circuit. What's that open circuit? Open circuit means mostly it comes from open switch. Closed circuit mostly comes from closed switch. If the switch are closed, then we can call as closed circuit. If the switch are on or the switch are open, then the switch are off or the switch are open, that will be called as open circuit. Okay, let's come to that. What is a closed circuit and open circuit? Okay, I'll draw two diagrams. Let's say here is a one resistor. Let's say here is a battery, and here is a switch. This much is enough, just to show. And one more. Okay. Now where's the difference between these two diagrams? Now here is a battery, and here also is a battery. Here is a resistor, and here also is a resistor. Mean resistor. Here is a switch, and here also is a switch. Where's the difference? Here is an open switch. Open switch. And here is a closed switch. Okay. And look here. What's the meaning of open switch? Open circuit. Open circuit means all the electrical appliances are connected in a circuit. Okay. But the switch are open. It means there are some wire. There are a wire which are going like this and not connected. They are not connected. Where? In open switch. In open switch means the switch are, okay, example in here is closed. This is closed. Now open means like this. Opens means like this. Okay, example if I join, then the water can flow. But if I open like this, will the water can flow? Or example, a car are moving in a road. Now here is a bridge. Then the car can move in this bridge. But if this bridge are open, can the car move? No. Then if the car can move, then nothing can carry here, this side. Car can move from here, but if this part is a brake means if here is open or brake, then nothing can carry this side, right? Then same for current. If this is closed, then the current can flow throughout. But if this is open, current cannot flow. Then if current cannot flow, mean that is the switch are open. Mean the electric bulb cannot glow. Example, if I draw here the electric bulb, this resistor we can represent for bulb also. Then this electric bulb cannot glow because when the current will flow like this. But when it reach here, it is open, then it doesn't have a way to go, right? Doesn't have to go because here is open, like this, open. Then the current comes, can't go. Here's an open or a brake. Then the current cannot go. Then this bulb cannot glow. Then there is no light. Okay. Then that is open switch or open circuit. Means there is some free end. These are the end, now they are free. Some free end, they are not yet connected. Means once there is a free end, when there is a break, then there is no current. Okay, can flow throughout the circuit. That is open circuit or open switch. Now it's a closed switch. Now closed switch means the current can move. Current can go till it reaches to this electric bulb and return back to negative terminal. That is a closed, that's continuous coming back between terminal, between positive and negative. Look here, the current will start from here and will travel till it reach to negative. That is a between terminal. Yes, between a terminal. Means it start from positive terminal and it move till it reach back to negative terminal. But here is a closed switch, then this wire are connected. Then the current can flow throughout this part and this bulb are glow. Got it? Then electrics. Now understand what is electric circuit? It is a continuous conducting path between a terminal. You understand here? Now the current will start from this positive terminal and go and passing through this switch and passing through some electrical appliances here, I don't know whatever it is, then electric bulb then return back to negative terminal. Okay. But here can it move? Yes, because the switch are closed. Closed means there is no free end. The free end are joined. then they can move, they can travel easily. But here the free end are open, then they can travel. Then this is open switch, then does not glow. Does not glow. Mean electric bulb does not glow. When you off the switch mean open switch or open circuit. Off the switch mean open circuit. On the switch mean closed circuit. This is open circuit. This will be the off the switch or bulb does not glow. Then this one will be closed circuit. This will be on position where the bulb glow. Here the bulb bulb glow, and here does not glow. Does not glow. It means why does not glow? No current can pass, because the current cannot travel, because there is no bridge, because the bridge are broken. Alright, open switch, open circuit means the bridge are broken. I can give an example for easy understanding. But in closed switch or closed circuit means the bridge are repaired. Then the current can travel. Got it? Now the definition for open circuit and closed circuit are similar to this only. Or you can check from your textbook. But I just want you to know, to understand what is open circuit and closed circuit. Don't confuse it. When it's a closed circuit, it doesn't mean off. Closed mean on. Closed circuit mean on. Why on? Because the current can fully travel throughout the circuit, then the bulb glow. That is on. Then you set on the switch, then the bulb are glow. Or when you on the switch and the bulb off. Okay, then that will be the topic of electric circuit. Then now we come to last, that will be series and parallel. Okay, let's start first this part. Okay, we have finished to talk about electrical symbol, circuit diagram, and then what else? Electric circuit. Then in the electric circuit we talk about closed and open circuit. And now we'll do about the series circuit and parallel circuit. Then we'll look what is a series circuit, what is a parallel circuit, and we'll draw some diagram and where's the difference, and we'll look what is the characteristic of each circuit, and then we'll do some derivation related to series and parallel. And after that we'll finish this part. Then in next class we will start with problem related to this. Okay, now I'll start with series. Series circuit. Or sometimes I call them as a series combination. Okay, combination of resistor. What is this series and what is parallel? Series means, by the name itself you understand what series. Series means okay, series means a connection. A connection, what I can say? A connection serially. Example, this is a one resistor, then again this is another resistor, then again this is another resistor, and connected end to end. Mean the tail of this resistor are connected to the head of this resistor, and the tail of this resistor connected to the head of this resistor. Mean all resistors are connected end to end in such a way that they will form a closed circuit. In such a way that they form a closed circuit. Then that is called series. What is a series circuit? A series is a connection. Is a connection of electrical appliances end to end. Okay, what do I write here? The connection. I told you generally that all the electrical appliances we call as resistor. And I write here the connection of resistor. The connection of resistor end to end. End to end. What's the mean this end-to-end? End-to-ends, that is the tail of one resistor is connected to the initial end of another resistor. In such a way that they form a closed circuit. Remember, for the circuit to flow, for the circuit to work, the circuit always has to be closed. If it is on, if it is an open circuit, then we have to switch on the switch so that we get what we do to do the process. Okay, then that's why, so that you form a closed circuit. Then such a circuit is called series circuit. Such a circuit is called series circuit. Okay, then let me give you an example with diagram. Let's say that, let's consider there are three resistors. Connected end to end. Okay, consider this is a one resistor. Okay, connected to another resistor. This is connected end to end. Now this is the tail of this resistor connected to the head of this resistor. Then the tail of this resistor connected to the head of this resistor. These are connected end to end. And in such a way that they form a closed circuit. Let's say here is a switch, and here is a supply source. Now this will be the series circuit. Let's say this is resistor R1, resistor R2, resistor R3. And okay, then parallel circuit. When I finish to write the definition of parallel circuit diagram, then we'll compare their characteristic. Okay, after that we will do derivation. Okay, what's a parallel circuit? You see here a connection of resistor end to end. But in parallel circuit, mean a connection of all the resistor. How many resistors we don't know? 3 or 4 or 5 or how many? But in such a way that they connect in only two common points. All the resistors are connected in only two common points. Okay, example I'll put here. There's one point here and one point here. Look here. This resistor are connected to this point. Now this resistor again connected to this point. Then again this resistor connected to this point. Mean there are so many points. Mean connect end to end. But here there's only two common end points. How many resistors connect? Thousands of resistors also, but there's only two common end points. Then that will be parallel. Okay, let me draw that. Let's say this is a diagram. Let's say this is a resistor. Now look, this resistor are connected to this point. This resistor are connected to this point. And this resistor are connected to this point. This means all these three resistors are connected only to two common end points. Then we do like this. Then this will be the source. Got it? Now what's different here? Okay, I've got a switch. Let me put a switch here. Open switch or close switch. Let's say this is a R1, R2, R3. Okay, how to write the definition here? A connection of resistor in such a way that a connection of a number of resistors. Forgot to write here. I got that here. Number of resistors. And here also, the number of resistors are connected in such a way that all resistors are connected at the two common terminal. I can say two common terminal because this is a negative and this is a positive. Okay, I can write definition that is the connection of n number of resistor. N number of resistor in such a way that all of the resistor are connected in two common point. I can say like that. Two common point or terminal. Connection of n number of resistors in such a way that all of resistors are connected in two common point or terminal. Common point and to form a closed loop. Form a closed circuit or closed loop. I can say closed loop or closed circuit will be the same. Okay, closed loop is called parallel circuit. Okay, now where is the difference and what from these two? What are their advantages? Which one having more advantages? This one or this one? You can guess. Which one has the more advantage? I'll explain you, then you tell me which one has more advantage. Here, the resistance connected are in series. Here, resistance connected are in parallel. But here, the total resistance overall are very large. And here, the total resistance overall are very small. Then remember, if the resistance are small, according to the formula of Ohm's law, I is equal to V by R. This is a formula that V is equal to I into R. Then, if the resistance are small, remember, look here, resistance is from denominator. If the denominator are small, then this numerator are increasing. Then, if the resistance are small, current will be large. But here, the total resistance are very large and the current will be small. Means the output current are very small. Because why the total resistance are very large? Then here, if you connect so many resistors, means so many bulbs, then that last bulb or that second last bulb they won't glow with high intensity of light. They'll just glow with dim light because they got only low amount of voltage, of energy supply. But here, how much you connect doesn't affect the intensity of light because the voltage remains the same. But here, look, once this voltage, this energy supply, once it reach here, it have to. Once it reaches here, this supply, it gives some energy. Okay, voltage. It gives some energy. Then the remaining energy will reach here. Then the remaining energy will reach here. Then the remaining energy will continue until it reduces very, very small and come back here. But when we total that all energy will have to equal to this supply energy. But here, the supply energy, the supply voltage is V. Now once you reach here, this same V will apply for this one, means the amount of voltage are the same for all the resistors. And here the amount of voltage are different for different resistor. Here, let's say the resistor voltage will be V1. Here, voltage will be V2. Here, voltage will be V3. What is this? I mean, here there is some loss of energy. That's what we call as voltage drop. And here also some loss of energy. That we call as voltage drop. And here also some loss of energy. That we call as voltage drop. Okay. But here, look here, voltage are different. Here the voltage remain the same throughout to all the instrument or to all the resistor, the voltage will remain V. The voltage will be the same because all resistors are connected directly to the battery, to the supply. But here, this resistor is not connected directly to the supply, it is connected first to this alternator, right? Then the supply energy to this one will get reduced. But here, all they are connected directly. Then the supply voltage here will be the same for all the resistors. Here the voltage will be the same throughout for all the resistors. And here, the voltage are different for all the resistors. The voltage drop for R1, drop in some loss of energy. Voltage drop for R1 will be V1, voltage drop for R2 will be V2, similarly for R3. But here the voltage are different, here the voltage are same. Then what about current? The current here will be the same throughout. Example, water. when it flows from here till here, there is some amount of water are taking out. Mean it lost something, that will be the voltage. Then it flows here. Again, who flows here? That water only, but again it takes some quantity. Then again it flows here. Again it takes some quantity. But who flows here? All are water flows. Mean all are current flows. Mean the amount of current here will be the same. But here the amount of current are changing because when there is a wave, this is, let's say the water are flowing here. But here there are two waves like this. But here are two waves. And some amount of water will flow this side, some amount of water will flow this side. Right? And similarly here, when current comes from here, then some amount of current will flow this direction, and some amount of current will flow here, then some amount of current will flow here. Then the current here are branched, meaning they are divided. And here the current remain the same, but here the current are divided. Okay. And how much they divide for R1 and how much they divide for R2, how much they divide for R3, it depends on the resistance. If the resistance R1 are more, then the current will flow here very less. Remember that. If the resistance are more, the current flows will be less. If the resistance are small, then the amount of current flows are large. Okay. Then that is from here. Meaning we got I is inversely proportional to R. Mean if the amount of resistance, if the value of resistance are more, then the current flows will be less. Got it? Then in parallel, the current are branches into inverse square, inverse ratio. Inverse ratio of what? Inverse ratio of resistance of a resistor. Then what's the name of this? Then that is, as the resistor are large, as the resistance are large, the current are small. When the current flows through that large value of resistance are small value of resistance, the current will be large. Mean if R is increased, then current will be decreased. Then if R is decreased, then current will be increased. In where? In parallel circuit. If example here, R1 are very small. The value of R1 are very small. Mean the resistance here are very small. Then the amount of current flows here are very large. Then here, if the value of R2 are very big, very large, then the current flows here are very small. Okay? And that is called inverse square. Here the current being the same, here the current are changes, are branches into inverse ratio. And that is, if resistors are small, current will be large. And here the voltage are dropped. Here the voltage will be the same. Got it? Then again right here, that is okay. Okay, this is called characteristic. What is characteristic of series circuit? What is characteristic of parallel circuit? Characteristic of series circuit are number one. The current flows throughout the circuit are the same. Throughout all the resistor of all the elements, the amount of current are the same. Through all the resistor, through all the elements in the circuit, the current are the same. The amount of current flows are the same. Then point number two, the voltage are different in each resistor, in each element of this circuit. Why? Because once the voltage are moving, it will get dropped. Once it reaches one resistor, again it will get dropped. Then when we total all the drop of voltage are very, very large. Now voltage will not actually it will remain as the supply, but resistance are very large. Okay, 1 point, current will same throughout the resistor. Voltage are drop in each resistor. Remember that, drop in each resistor, and then the total resistance here are very, very large. The total resistance here are very large. That are the 3 points. Then you can write here. Point number 1. Current. I was right. You already got. You can know it. Point number 1. The current flows in each resistor are the same. Then point number 2, the voltage are dropped in each resistor. Then point number 3, the total resistors are very large. Then here the current are branched into inverse ratio. Here the current are branched into inverse ratio. That is means if the resistance are large, the current flows through that resistor. If the resistance are large, the current flows through that resistor are very, very small. Point number 1, the current are branched into inverse ratio in each resistor. The current are branched into inverse ratio in each resistor. Then point number 2, the voltage through all the resistors are the same, and the total resistance or the equivalent resistance are very small. Okay. Then here I can write that is because here the current are changing. Then I write this. I is equal to I1 plus I2 plus I3 because we take 3 resistors. If 4 then I'll plus 1 more I4. If 5 then I'll plus 1 more I5. Okay. Because here the current are changing, then this I is the total current supply. Because the current here, now this is the supply current. When it is here, divide. Okay, then I is equal to I1 plus I2 plus I3. But here, in series, supply voltage is V. But when it is here, it drop. Then I'll put here V1 plus V2 plus V3 plus V4 plus V5. Got it? Now, these are the series and these are the parallel. Then here I can write the total resistance. We will derive that. I put like this RP, mean resistance in parallel. Resistance in parallel. This is equal to 1 by R1 plus 1 by R2 plus 1 by R3. We will come to this. This will be the last part. This part we will do from where we got that. Then here RS, resistance in series. And this will be R1 plus R2 plus R3. This will now we'll do this one. Okay. Now if I ask you what are the difference between series and parallel, you got it right? Those 3 points will give you, and plus you write the definition 4 points. And if you want 5 points or so, you can write it 1 more point and give you. This series circuit, it is not used in household distribution. Which circuit are used to distribute electric supply at home or all the wiring in your household? That will be parallel. Mean parallel circuit are used for the distribution of electric in household. Then series circuit does not use in household. Then where it used? Usually some program, some function, some special function. And in most of the case, this R. Then this will be the best one. More advantage will be lies on this. Okay, then now we come to last part. This one and this one. This R3 is a resistance in parallel that I can call as equivalent resistance. RS resistance in series, equivalent resistance of series circuit or series connection. Okay, now come to the derivation of that formulas of series circuit and formulas of parallel. Okay, I'll start with series. And more question. Here I said this: derive an expression for an equivalent resistance. Derive an expression for the equivalent resistance in series connection. Okay, expression. Derive an expression for an equivalent resistance. Derive an expression for an equivalent resistance. In a series circuit. What is this equivalent resistance? Equivalent resistance also we can call as a total resistance. Total resistance in series. Okay. Let me do this. Let me assume there are 3 resistors connected. Okay. We won't consider more than 3. Or you consider 4 also is okay, 2 also is okay, but let's take generally 3. Now consider solution. Consider 3 resistors. Consider 3 resistors connected in. Consider 3 resistors of resistance R1, R2 and R3. Consider 3 resistors of resistance R1, R2 and R3. What's the resistance of that resistor? R1, R2 and R3. You remember what's the SI unit of resistance? Remember? That resistance unit of resistance is Ohm, that we define from Ohm's law. Okay, consider 3 resistors of resistance R1, R2 and R3 connected in series. Then let V is the supply voltage. Let V is the supply voltage, and then I is the current flows throughout the circuit. And then V1, V2 and V3 is the voltage drop. Across each resistor. So why put this V1, V2 and V3? Voltage drop across each resistor. Remember that in a series, voltage are different. In each resistor, the voltage are getting dropped, but the current remain the same. That's why for current, I don't put I1, I2, and I3. Okay. Then one more. RS. This will be the equivalent resistance or the total resistance. Total resistance in series. This S stands for series. Okay, let's draw the diagram. Also 3 resistors. Okay, 3 resistors. 1, 2, 3. Let's consider here. There's a switch, and here's the supply voltage. Let me change the direction. Here positive and here negative. Okay, let's say this supply voltage here is V, voltage V, and here a resistor R1, resistor R2, resistor R3. Consider here the voltage drop here will be V1. Consider in this one the voltage drop will be V2, and here the voltage drop will be V3. Then the current here flows throughout the circuit will be I. Okay, now then go back from that characteristic. In series circuit, the voltage are different. That we put V is equal to V1 plus V2 plus V3. And now for series connection or series circuit. For series connection, voltage are defined as V is equal to V1 plus V2 plus V3. This V is a total supply voltage. This is, and V1 are the voltage drop across resistor R1, V2 across resistor R2, and V3 is across resistor R3. Then, but from Ohm's law, V is equal to, what is V? What's the formula from Ohm's law? V is equal to I into R. I into R. But this V is a total voltage or supply voltage. Then I will remain the same for our circuit. I can change. Then if V is a total voltage, then what is this R? Then R will be the total. Then I put here RS. If V is the supply voltage or the total voltage, then R also should be the total resistance or the equivalent resistance. Then V1. V1 is equal to I into R1. I told you the amount of current flows throughout will be the same. Then that's why I does not change. But now voltage drop V1 is on this resistor across R1. That's why I got here R1. And then V2 is equal to I into R2. Then V3 is equal to I into R3. Then let me put this as equation 1. Now substitute all this value in 1. Okay. Put it here. Substitute the above values in equation 1. We get. Okay. Substitute all this value. In place of this V, I put IRS. In place of this V, IRS. In place of this V, I put IRS. In place of V1, IR1. IR1. In place of this V2, IR2. Then, in place of this V3, IR3. IR3. Now here also I, here also I, here also I, here also I. Now look at this. IRS. And take common. I into R1. I into R1, IR1. Then plus. I into R2, I into R2 will be IR2. Then plus. I into R3. I into R3 will be IR3. I mean I have taken common, take outside. Then I and I get cancelled and got here RS is equal to R1 plus R2 plus R3. Look, that when we explain that characteristic, I write this one, right? That RS is equal to R1 plus R2 plus R3. Now this is the total resistance or total equivalent resistance in a series circuit is equal to the sum of the individual resistance. Okay, and here RS is greater than R1, remember that. RS is greater than R2. RS is greater than R3. And remember, RS is a large amount of resistance. Okay, now let's come to parallel. For parallel, conserve 3 resistor, say for next part. Okay, same question. Derive an expression for the equivalent resistance of a resistor connected in parallel. Now the question are changing in parallel and here in series. Then I'll do like this. Consider three resistors of resistance R1, R2, and R3 are connected. Okay, I forgot to put this in that part. You go at this one. Are connected in parallel. Now changing parallel. Okay. Now change to parallel. Then here, let V is the supply voltage. That will be same. I current flows. I now is changing. Because here in parallel, which are changing? Voltage are the same, but current are divided into branches. And here are I is the total current. Total current flows throughout the circuit. And then in parallel, it is the potential are changing or current? Current are changing. Then this V1, V2 all are removed. Then I put here I1, I2 and I3. This is the current across each resistor. Current flows across each resistor. Across each resistor, which resistor? R1, R2 and R3. Yeah, not yet drawn the diagram. This is not the diagram, this is the series. Okay, then here RS, I put here RP. RP is the equivalent resistor. Okay, now we got V is the supply voltage. Now in parallel we are made the same, that we don't need to write V1, V2, V3 because there is no voltage drop because the voltage are the same for all the resistor. But the current are branches into inverse ratio. That's why I put here I1, I2 and I3 because the current are changing. Then RP is equivalent resistor. Okay, then what else we need? This much only. Then let's draw the diagram. Okay, now these are connected in parallel because all the resistors are connected in two common endpoint. This is one point and this is one point. And this resistor connected to positive terminal. This connector is connected directly to positive terminal. Now let's say this is supply voltage will be V. Then the current here will be I. But when it reaches here, this current are divided into. This current when we reach here divided into I1, I2 and I3. Because water once it flows, but if there is open this, then the water will, some amount of water will flow this direction, some amount of water will flow here, some amount of water will flow here. And same for current. Then current is like water. Okay. And voltage is like the function of water. Here what's the function of this water? We in this water are giving to the supply to the agriculture. Then that again after reducing to the agriculture, then again they will return back and mix somewhere. And this also again after using somewhere, again there will be somewhere. Right? Then same for voltage, same for current. Now we are going from here and then we back here. Same for water. Then what else here? Okay, switch also is a closed switch. Remember this one. Now remember in series voltage are different. Right? Then we put V is equal to V1 plus V2 plus V3. But here the voltage are the same. Then we have to take current. Current are branches into inverse ratio. Means current are branches into inverse ratio. That is I is equal to inversely proportional to R. If R is large, then current will be small. If R is small, then current will be large. That is meaning of inverse ratio. Now, then what we have to do? I is equal to I1 plus I2 plus I3. How much the current are branches? But when we total them all, they have to equal to the total given total supply amount of current. Okay, let me put this as equation 1. Okay, but from Ohm's law, what's the value of I? What's the formula for I? From Ohm's law, formula is V is equal to I into R. And from here we can get I is equal to, from here we can get I is equal to, take this R this side, you will change to, because here is a multiply, then you take this side, change to division. Then we got V by R. Then I is equal to V by R. Then here, this I is a total current. Then V is does not change, whether total or separate, V will remain the same. Then V by R. Then R has to be total. Then what's the total here? RP. Mean resistance in parallel. Total resistance in parallel. Then I1. Similarly for I1 will be V by R1. Remember, voltage does not change here. Voltage remains the same. Then I2, V by R2. Then similarly, I3 is equal to V by R3. Okay, now let's substitute all these values in equation 1. Substitute the above values in equation 1 we can. Okay, now in place of this I, how much we got? V by RP. We can put like this. V by RP. Then in place of this I1, V by R1. And put here V by R1. Then in place of R2, in place of not R2, I2, in place of I2 we got here how much? V by R2. And put here V by R2. Then similarly for I3, V by R3. Okay, now here also V, here also V, here also V, here also V. We will do same like in series. We'll take common, but here I do this V by RP. Then V taking common V. Then put this here. Okay, I do here. I do 1 by RP into V. Can you do this? Because V into 1 will be V. Because 2 into 2 will be 2 into 1 will be 2. Then 3 into 1 will be 3. Because anything multiplying 1 will be anything. Then similarly here, anything multiplying 1 will be anything. Then V into 1 will be V. And similarly here also, V into 1 will be V. Then plus V into 1 will be V. Then V into 1 will be V. Then V and V cancel. Then we got here 1 by RP is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now this will be the total. This will be the formulas of correction in parallel. And remember, in series, RS is greater than R1. RS is greater than R2. RS is greater than R3. In series, mean the total resistance are greater than all the individual resistance. But in parallel, this RP are the smallest. This RP is smaller than R1. And this RP is smaller than R2. And this RP is smaller than R3. Mean the total resistance are small. That is very, very nice in parallel circuit. Okay, then remember this one. Remember that RS is always greater than RP. Then this will be the maximum resistance. Maximum resistance. Then this will be minimum resistance. Please remember this. Maybe there's a question in your textbook. I'll ask you to do homework to try this one. Okay. In that case, they give a question like this: find the possible minimum resistance. Assume that there are 4 resistors. They don't say they are connected in parallel or in series, but they just said minimum resistance. Then what is minimum resistance? Minimum resistance is resistance in parallel. Maximum resistance is resistance in series. Remember that the total resistance in parallel are always less than the total resistance in series. Okay, then those difference between series and parallel, please write it. Is there is also in your textbook. If you don't understand properly my language, then you can check it from your textbook. They give it, and please just write it. Note down. Don't copy all those words written in this textbook. It's just boring for you to read, and also it's just like you once you read, also you won't get it. That is why I explain you. And please write it. The difference between the series circuit and the parallel circuit. Then this will be the end of this video, and in next class or in next video we will start with a problem related to this topic what we do today. And let me give you one question. That will be okay. From your textbook only, the question will be in page 137. Question will be page 137. Question number in question number 1-4. Question number 1-4. That will be MCQ, multiple choice question. From multiple choice question, page 137, question number 4. Please try this question. Okay, and those who already have the answer, because that's multiple choice, maybe you have all textbooks already, you get the answer, and please try to solve how that answer came by using with the help of these formulas, either this one or series, I don't know whatever it is, but you check that question and solve it. Okay, and thank you.